Hello guys, in today's video I'm going to explain how you can name IUPAC nomenclature of coordination compounds. Okay, this is one of the units in 12th class from chemistry, and coordination compounds, any coordination compound contains a complex part. A complex part is written in a third bracket, in which a central metal is there, M, and this will be surrounded by ligands of some coordination number. This can be 4 or 6, mainly 4 or 6 or 5. Okay, 5 is less common. So this is a complex, and in this video I'm going to explain how you can name the coordination compound, the IUPAC name. Okay, so before that let me give you the steps. Rather than rules, I'm going to give some steps to write IUPAC name. Okay, so this is the step number 1. Step number 1 is, or let me write here steps. Okay, first of all you need to write the name of the cation. This is known as anyone, then what, anion. Okay, for example sodium chloride. In sodium chloride we name this cation first, sodium, and then anion this chloride. Okay, likewise any coordination compound must be named this way only. First of all we must name cation and then anion. So the cation can be a complex, or the anion can be a complex, or both can be the complex. So next step is either this cation or anion must be a complex, or the complex can be neutral also. Okay, so how to name a complex? This is the second step. So how to name a complex? Let me erase it. Okay, now this complex can be and must be named in this order only. This is the actually order. Okay, this is the order that I'm going to write here. Order, any complex must be named in this order only. First of all we must write the names of the ligands in alphabetical order. Okay, in alphabetical order. Okay, after the ligands we must name the central metal. Okay, after naming the central metal we must write the oxidation number of the central metal in this parenthesis or first bracket. Now one important point here is that the central metal, okay, the central metal, naming central metal has two ways. If the charge of the complex is either cation or 0, means cationic complex or neutral complex, the central metal is named as it is. This is my rule. Okay, and if the charge of the complex is negative, that is anionic complex, then the name of the central metal is named plus ATE. For example, if I need to write platinum, if the charge of the complex is positive or 0, it must be named as it is. Okay, means we must write platinum only, platinum. Okay, but if the complex is an anionic complex, then this must be named as platinate. Okay, this must be named as platinate, correct? Okay, and if the central metal is, for example, gold, then in this case gold only, but in this case this must be written as orate. This comes from the word aurum, okay, for gold. Okay, this is A. Now another example, copper. Here we need to write copper only, but in this case we need to write cuprate, like this. And many examples are here for cobalt. This has to be cobalt only, and in this case it has to be cobaltate, like this. Okay, these are the steps or rules, you can say, correct? So let me take one example. Suppose this is the coordination compound. For example, let me write here Cn, 4Cl2, like this. This is the complex. Now this is the complex part, this is the counterion. This is the counterion, or this counterion is positive charge, and the charge to complex is negative. This is the cationic part, and this is the anionic part. So according to the steps or rule, the cation must be named first and then anion. Okay, so its name is potassium. We must write potassium first, because what is potassium here? Potassium is the cation, so we need to write the name of the cation first and then anion. So the anion is a complex. So for naming a complex, we need to follow these steps or this order. So this is our central metal, these two are ligands, right? So these two ligands must be named in alphabetical order. Cn is cyanido, and Cl is chlorido, CH, and the cyanido means CY. So this must be named first. So let me name the complex now. So for writing complex, we must name ligands first, and then central metal, and then what? Oxidation number of the central metal. So this is the central metal, this metal, these two are the ligands. So in alphabetical order, we must write chlorido first. So how many chlorine atoms are there? 2. So we must write dichlorido. This is the first ligand, and the second ligand is cyanido. How many cyans are there? 4. So tetracyanido, cyanido, okay, or cyano, you can say, dichlorotetracyanido. These are the ligands, and then central metal is cobalt. So whether we write cobalt or cobaltate, that depends upon the charge of the complex and in this coordination compound the complex is negatively charged, so we must write cobalted, not cobalt. So after cyanide we must write cobalted. Okay, cobalted. So after naming the central metal we must write the oxidation number in this first bracket. So let me calculate oxidation number of this cobalt here. Potassium is +3, potassium is +1 actually, so there are 3 potassium atoms, so potassium ions actually, so +3, and let me take oxidation number of cobalt as X. Cn is -1, -4, Cl is also -1, -2, -4, and -4 and -2 are -6, and this must be equated to 0. So X comes out to be +3. So this is the oxidation number of cobalt, of the central metal, so we must write 3 here like this. Okay, this is the IUPAC name of this compound. I hope it is clear. Let me take some more examples. So for that, let me go, let me rough this page, that will be better. Okay, I'm keeping this order steps here. Let me erase it. Okay, now let me give another example. Second example. Okay, second example, let me write this complex CO, what shall I write? CONH3, NH3 is NH4, and let me write 2 water molecules as ligands, and here let me write chlorine, 3 chlorine atoms. Okay, so first of all let me identify which one is the cation and which one is anion. So this part is our cationic part, this is our cationic part, this is our anionic part. Okay, so cation must be named first. Since our complex is the cation, so we must follow this order first: ligands, central metal, oxidation number. Okay, so ligands are ammonia and water. Ammonia is amine, water is aqua, AQ, and amine AM. So M comes before aqua, Q. Okay, so we must write amine first. And how many amine? Ammonia is named as amine in coordination chemistry. Okay, so amine tetra, because 4 ammonia ligands are there, tetraamine, and then diaqua, right? Diaqua, water is aqua. Okay, these are the ligands in alphabetical order. Then we must write the name of the complex, central metal. After ligands we must name central metal. So central metal here is cobalt. So let me write cobalt, because the charge of the complex is positive. If the charge of the complex is positive, then we must name central metal as it is. So cobalt, let me write cobalt only, and then oxidation number, and then oxidation number. Okay, so let me calculate oxidation number here. Oxidation number of cobalt is, suppose, X, and the ammonia is neutral, water is neutral, so +0. Cl has a negative value, negative sign, so -3 will be there, and this will be equated to 0. So this gives our value of X as +3. +3 is the oxidation number of cobalt, so 3 must be written here like this, right? So this is our cationic part. Since the cation is complex, so I have written in this order: ligands, then central metal, cobalt, then oxidation number. Now I need to write the anion. And what is the anion here? Chloride. Now, no need to write trichloride because this 3 is just to neutralize the charge of the cation, okay, charge of the complex. So the anionic part is, we need to write what? Chloride. Correct. This is the name of this complex, right? So let me go to a new page for another example. Let me write third example, okay? And in this case, let me name this complex, which is this one, okay? Pt, platinum, NH3, how much? 3. Br is there, NO2 is there, NO2, and then Cl is also there as the ligand, and one counter ion is there, Cl. So let me name this complex. Coordination number of platinum in this complex is 6. How many ligands, how many ligands, monodental ligands, okay, or how many coordinate bonds are formed by this central metal is called its coordination number. So with 3 ligands, Br, NO2 and Cl, this platinum central metal will form 6 coordinate bonds with this ligand, so its coordination number will be 6. But I don't need coordination number here. Okay, now let me identify the cation and the anion here. Okay, this is our cationic part, and this is our anionic part. So again, the cation is the complex. For writing complex, we need to write the ligands first in alphabetical order, and then platinum, and the name of the central metal and its oxidation number, then its counter ion, means anion. So let me write this complex first, since it is the cation, and for writing complex, the ligands must be written in alphabetical order. This is amine, this is bromido B, this is chlorido C, this is nitrito N. Okay, so in alphabetical order, I need to write amine first. Okay, so this is amine. How many amine are there? Ammonium molecules is 3, so I need to write tri here. Okay, triamine. Then bromido, you can write bromo also, but this is the new convention. And then comes chlorido, then nitrito N. Okay, then what? Nitrito N. This is the name of the ligand, right? So these are the ligands in alphabetical order. I have named the 4 ligands: amine, bromido, chlorido, and the what? Nitrito N in alphabetical order. So now I need to write the name of the central metal, which is platinum, because the sign of the complex is positive, so I need to write platinum, not platinate. So this is our central metal, this is platinum. Okay, so after writing the central metal, we need to write the coordination number here, oxidation number here. But before that, let me complete this anionic part also. So the anionic part is chloride. Remember, here Cl is also present as the ligand, but this Cl is the counter ion. Actually, this Cl is the ligand, this Cl is the counter ion. Okay, so for naming a ligand, we need to write this word chlorido, but for the counter ion, we need to write chloride, not chloride. Okay, this is the counter ion, chloride. So let me calculate the oxidation number of platinum here. Platinum is X, for example. Ammonia is 0, bromine is -1, nitrito is also -1, this is plus. Okay, Okay, now Cl is also -1 oxidation number. This is also -1 equated to 0. So -1, so X is equal to +4. So this will be 4, like this. I think this is clear. Let me give one more example, which is somewhat I think this will be somewhat tough. Okay, let me write with this color only. Okay, let me take a somewhat tough example. Not tough actually, don't worry. This is a nickel and it is written as C2O4, and this is En2. Question may be asked in this complex as how many, so what is the coordination number of nickel and oxidation number of nickel? Let me calculate the oxidation number here. Nickel is what? Oxidation number of nickel, let me take the oxidation number of nickel as X. This is C2O4 is oxalate ion, oxalato. This has a -2 charge. Okay, this is -2. En is neutral ligand. These two are bidentate ligand. Okay, so coordination number will be 2, and 2 into 2, 4, 4 plus 2, 6. Coordination number of nickel in this complex is 6. So nickel, this is -2, and this must be equated to what? This +2, because this is an ion. Okay, so oxidation number of nickel in this complex is +4, right? I think this is right. X -2 0 equated to +2. Okay, this is correct. And this is the what? Oxidation number and the coordination number. Let me write the coordination number here also. This can form 2 coordinate bonds. En is ethane 1 to diamine. This is also a bidentate ligand. This can form 2 ligands. So this can form 2 coordinate bonds. So 4 coordinate bonds will be formed by 2 En molecules and 2 from 1 oxalate ion, right? So coordination number will be 2 plus 4, that is 6. Okay, let me write the name of the IUPAC name of this complex ion. So this is just a cation. Okay, and the cation is complex, so we need to write ligands in alphabetical order first, then nickel. Okay, so oxalato is O, starts with O. Ethane 1 to diamine starts with E. So let me write ethane 1 comma 2 diamine, right? Ethane 1 to diamine, this is En, and how many En molecules are there? 2. So there is a one rule: if the name of the ligand includes this word di, tri, tetra, then to denote 2 such ligands we need to write bis, not di. Okay, so for 2 En molecules we need to write bis, not, remember, not di. Okay, because the name of the ligand itself includes the word, the prefix di. Okay, so for 2 molecules of En we need to use this bis instead of di. So bis ethane 1 to diamine, and then oxalato, this is oxalato. Okay, then nickel, we must write nickel, not nickelate, because this is a cationic complex. The charge of the complex is positive, so we need to write nickel. And then oxidation number of nickel is 4. This is the name of the complex, right? Last example, let me give last example here. Okay, let me clear it, and let me take one more example, 5th example, which is this one. Okay, this is the fifth example. This is Fe and this is PPH3, and this PPH3 molecule is 3, and then ammonia is there, then chlorine is given, then bromine is also given. This is the complex, and one counter ion Cl is also there. Okay, let me name this complex, this coordination compound, and before that let me again identify the cation and anion this complex. This complex part is our cation and this is our anionic part. So we must name this cation first, and since the cation is the complex, we need to write the ligands in alphabetical order first, and then what? Then this central matter. So what is this PPH3? PPH3 is, triphenyl phosphine. Let me write PPH3 is triphenyl phosphine. What is phosphine? Phosphine is this PH3 is phosphine, and if these 3 hydrogen atoms are replaced by 3 phenyl group, then this is our triphenyl phosphine, right? So the structure of triphenyl phosphine is, this is phosphorus, and to this phosphorus 3 phenyl groups are attached like this. These are the 3 phenyl groups. Benzene ring is there, phenyl is the benzene. This is PPH3. Okay, and this is a neutral ligand, and this is ammonia, again neutral, Cl is negative, Br is negative, right? So first of all, let me calculate the oxidation number of iron in this complex. Oxidation number of iron in this complex. Let me write iron as X, and the triphenyl phosphine is 0, ammonia is again 0, Cl is -1, Br is -1, and again counter ion Cl is -1. Then this must be equated to 0. This gives X is equal to +3. Okay, so now let me name this complex first, and then counter ion chloride. Okay, so triphenyl phosphine, in the name of the ligand itself, tri is there, so for 3 triphenyl phosphine we need to write tris, not tri. And the triphenyl phosphine starts with T, amine A, so we must write amine first. So name of the complex is amine, first amine, and then what? Bromido, I think. Okay, this is bromido, then comes chlorido. Okay, then what? Tris triphenyl phosphine, tris in bracket triphenyl phosphine, right? These are the ligands in alphabetical order. After the ligands, we need to name, all names have been mentioned, 4, 1, 2, 3 and 4. Okay, now this is iron. Since the charge of the complex is positive, we need to write iron only, iron, and then coordination number of iron, and the coordination number of iron is +3, right? This is +3, and then this is the cation, then we need to write the anion. What is the anion here? Chloride, right? This is the example of some coordination compounds. And for today, for this video, let me complete here, and please like this video, share with your friends who are preparing for class 12 board or council, or for those to your friends who are preparing for NEET also. And if you are new to the channel, please like, please subscribe this channel also. Thank you.